This is the STS-119 interview with Mission Specialist Steve Swanson. Steve, would you tell us the story about how and why you decided to become an astronaut?
Sure, no problem. It started back in graduate school when I was getting ready to graduate from graduate school and had to come up with a job that I was going to do for the rest of my life. And at that point I really didn't know for sure. I knew I liked science and engineering. I just didn't know exactly where in that area I was going to work. And so I started thinking about really what I want to do for a long time and what would excite me and keep me interested. And that's when the astronaut idea came in my head. And so I started looking into it at that time. I still wasn't really qualified for the job at the time. I don't know if I'm even qualified at this time, but I'm doing it. So I started looking into it and started going towards that goal at that time.
And once you made that decision, tell us about how you actually got here. What educational steps and professional steps did you take?
I started to work in the engineering field after I got out of my graduate school after the master's, and applied to NASA. As an astronaut, beginning wasn't qualified, so after about a year, they actually gave me a call and said, "Hey, do you want to just come work for us and learn more about NASA and how we operate and get some experience?" So I said, "Sure," and came to work at Aircraft Operations Directorate, working on the shuttle training aircraft. Starting off as an engineer and then a flight simulation engineer. And that was a great job, a wonderful job I had there. You had to combine both the engineering aspect of a job and also the flying aspect, which made it very enjoyable. Really liked that job. And after about 11 years of that, I got selected as an astronaut. And of course, while I was doing my time at Aircraft Ops, I went off and got a PhD also at that time. I think that does help when you're trying to become an astronaut.
Tell me about the place that you consider your hometown and how that place influenced you and the things that you've accomplished.
I consider Steamboat Springs, Colorado my hometown. It's a beautiful place. What I think it helps me in achieving my goals is more the fact of just an outdoor, self-reliant type attitude that you have there. And I've used that, I guess, throughout my career here and just in my life. I do like doing outdoors. Maybe it helps on spacewalks, you know, going for a big hike outside in inclement weather. But overall, it was a wonderful place to grow up. Gave me great memories.
Where is that close to?
It's in northwest Colorado, not close to very much.
Okay.
In the mountains, like 40 miles from the Wyoming border, little 120 miles from the Utah border, and no other big cities nearby.
So it kind of helped you appreciate the being an explorer, basically.
Yes, exactly. I did. As growing up, I loved to explore and go for hikes, not even follow a trail, just go off and go find and get to the top of a mountain somewhere. So I really think that kind of idea of exploration was set in my brain at that time.
What or who helped you realize the value of education in life?
I think my parents definitely drove in the fact that education was very important. It was never an option, really, of what you're going to do with your life in the sense of getting a good education. And as you just look around in the world, you see that the people that you want to emulate or be like had education as part of their background. And the jobs I want to do needed education also. You combine all it together, it was just, for me, an idea that I had no choice but really to go on and get a good education. And again, thank my parents for allowing me to do that. That was a wonderful opportunity, and I do appreciate that.
What's it been like working with these crewmates as you've trained for this mission? Tell me about some of the relationships and some of the intangibles that you've seen in your crewmates.
Oh, well, one way it's been very difficult because they're all smarter and work harder than I do, so it makes me look bad. But besides that, they're a great bunch of guys, and I do enjoy it very much. We have a good time. As with any crew, you get along on a mission, and you've been working with somebody for 9 months. A lot of inside jokes going on, so we have a good time with that. But they're also all very competent people. I enjoy their work ethic, and they are also very intelligent, smart type people. And it's fun to work with people like that who are very competent and they get the job done. And then at the same time, though, they can also have fun, and it's a good mix.
Can you take a moment and maybe go one by one and tell us a little bit about what impresses you about each one of them?
Oh, you want me to give positive attributes about my crewmates? That's not going to happen. No, I mean, I can tell you that they are, let's see, start out, you know, our commander, Lieutenant Bo, we go by Brew, we call him Brew. It's a good story if you ever want to ask him that one. He is, again, a competent individual. He is very organized, tries to keep, which is his job, and he keeps us very much on the right path in the sense of our schedule, which is a very difficult thing to manage during a training flow. We have lots of different things pulling us in different ways, as you say. And he keeps that all under control and makes sure that we're training on the right things and we're not training too much in some areas and too little in other areas, and that our time is not being wasted anywhere. So he does that very well. And it takes somebody with a lot of discipline and diligence to do that job, and he definitely does that. But he also has a nice dry sense of humor, which comes out once in a while, which is nice to see. Our pilot, Tony Antonelli, he's a Navy man, and I say has a good demeanor of a Navy man. He's good, again, dry wit, but also very competent at the same time. And we definitely do a lot of the, I guess, Navy-style jokes with him. Fun guy. But again, a very, very good pilot. Knows his systems very well on the shuttle, his job, and hopefully he can clean a very good toilet. Next would be Joe Acaba, MS-1. I've been working with Joe a lot because he's one of the EVA guys with me. Again, he and Ricky both are some of the hardest working, diligent type of people you could ever imagine. They've taken on task and done much more than I ever did in my first time doing this job when I did my first mission 2 years ago. They've worked so hard at it and become so competent, it's amazing. It's just very impressive, their abilities. But then again, at the same time, I enjoy being around them. They got a good sense of humor. We have a good time talking to each other. It's just fun to be with them. Enjoy it.
And John Phillips?
And John Phillips. He's the old salty dog of the crew. Huge amount of experience in space and in life, period. He definitely is a great to have on the crew, a very good asset. Again, he likes some mountains like I do. He also, we have a good time, I guess, joking around with him also. We all, as a crew, he takes it well because we do rib him a lot about his age. And Koichi. Koichi is a fantastic person to begin with. Amazing, again, just a impressive person to be around. The guy is amazing. I mean, he always got the term "the man" from his earlier missions because he was so good at everything. Well, I've determined he's actually more of a demigod, but he's just an amazing person. Very nice, type of guy that is always considerate towards everybody, and at the same time, though, is super competent. Really nice guy. Unbelievable.
And your crew will deliver Koichi Wakata to ISS to be JAXA's, the Japanese Space Agency's, first long-duration astronaut on ISS. That's a milestone for that space agency. How does it feel to have a role in doing that?
Oh, it's very nice. I'm honored to be part of the space agency or space program anyway. And so it's great for JAXA and the Japanese people. I mean, they've worked very hard, spent a lot of resources on the International Space Station. Now they get to see some of the fruits of their labor come out. They get to have a Japanese person on board the station living, and I think that's just a great thing for them, and I hope they enjoy it tremendously. It's a great honor.
There are thousands of people behind the scenes that work hard to make this and every mission a success. What are your thoughts about their contributions, and what's it like when you get to meet these people during your travels for training?
They do a fantastic job in their contribution towards the space program, actually probably more than we do as astronauts. They're just an amazing group of people because they usually do all the things that is needed to get the job done, and sometimes without management help. As you know, it's a political agency. Sometimes it doesn't go as smoothly as you'd like, but these people, no matter what happens, they always get the job done. I find that amazing. And I've worked with many of them just working in flight control systems, or sorry, in the mission control as a Capcom. So we got to meet a lot, work with a lot of them, and that was very enjoyable. I mean, they do a fantastic job in mission control on getting us ready, the vehicle ready, keeping it everything running smoothly. It's a great thing. And then from our trainers to the engineers, everybody's just fantastic. And they make sure we're ready to go. The engineers make sure all the systems are well thought out, work well. It's just a great team effort they have here at NASA.
Tell me a little bit about what it was like for your first space flight when you took that, and your first EVA, just coming out of that hatch, just the whole.
Yeah, it's an amazing experience. It's really hard to even describe. I found most interesting, or what I liked the most on the space flight almost, was just being in a microgravity environment, just floating around. Found that made everything fun. It was always just interesting to do everything new at that time. I felt like I could have been there for a long time and enjoyed myself. But of course, one of the highlights was doing the spacewalk. And that is amazing. I came out the hatch. It was nighttime when I came out the hatch, so it feels just like you're in the pool, the NBL. And that made it no big deal coming out at all. And I worked my way up to the top of the station at the time, was where P6 was on the top. So I got myself up there in position for our task up there, and that's when the sun came out. And that was an amazing view. It was just heart-stopping. Yeah, hanging on the top of the station, you look out and the sun comes up and you could see the station with the Earth below. And it was just, I couldn't work there for a few minutes. Had to stop and just look at everything and take it all in. It was amazing.
Did you by chance get a chance to see your hometown from space, or that area? Did you guys?
Sure, not while I was outside, but during the mission we did. And that was nice. It's amazing. It still looks beautiful from up there. But yeah, I found out was also amazing. I thought as you go around the Earth and see many different parts of it, places of course you've never been, that you find out there's many places on Earth that look just as beautiful, just like that. And you'd love to go explore those areas too. I found that I didn't realize how much was out there that you still have no idea about or would love to go see.
Okay, could you summarize the main goals of this mission? What will you and your crew be trying to accomplish?
Well, one of the goals, of course, is to take Koichi up and bring Sandy down. The next one would be the S6 truss when it's solar array, and get that all on and deployed and generating electricity. I think that would be our main goals of the mission. We do have some transfer items we need to bring across and help out for the space station. And then from then on, it's tasked to help the station be in a better configuration for the next 10 years.
And as a mission specialist, what are some of your main roles and responsibilities on this mission?
As mission specialist 2, it's a flight engineer spot on ascent and entry. So I'll be on the flight deck helping the pilot and commander through the ascent and entry phase of flight. Which is a wonderful spot to be in for a mission specialist. I enjoy that tremendously. So I have that. After that, my main task is to lead the spacewalks. We'll have 4 spacewalks. I'll be out on 3 of them, first, second, and fourth. And for the third one, I'll be the inside quarterback or choreographer. We call that the IV. I'll be doing that job for the third one.
Could you give us your best description of the S6 truss and its attached solar arrays?
Sure. My best, so it's not very good. I'll start off with that. It is a metal structure that is going to be about, well, let me put it this way, it fits in the payload bay just enough. And so it's be probably around 35 feet long, I believe. It's pretty much, I call it a square shape-ish type, and with the sides being around 10 feet long. It will have a spacer part, which is just structured to get the solar array farther away from the closer in solar array on the space station. And then it'll have a solar array section with batteries and associated electrical components of that out there. When it's launched, it has to be in a launch configuration, which means all the solar arrays are bolted down in a configuration so that when the shaking of launch will not damage them. And so when we get out there, the first thing we have to do, of course, is get it in a configuration so that we can deploy the solar arrays. I believe it weighs around 31,000 pounds.
And once S6 and its solar arrays are attached and activated and deployed, tell us about the change in capability for a station and the look of it.
Well, first of all, it'll be symmetric, which is to me, a very important thing. We did it on 117 and we're doing it on 119, making the station symmetric. It'll finally look like those artist renditions of years ago of what space station should be. And for power-wise, we'll increase it about 33%. We're going from 3 solar arrays to 4 solar arrays. So that will be a great addition. We can now do more science, even bring more modules on. It will be a great help, I think, to the International Space Station.
How would you characterize the job that the STS-126 crew did during their mission on the starboard side solar alpha rotary joint and its relevance to your mission?
They're terrible. No, they did a great job. In fact, right now, from the data, we've been told that the solar alpha rotary joint is working well, or at least definitely a lot better, and it probably can use it. And that will help us tremendously since our S6 goes on the outside of that. And the idea of that joint, of course, is so that the solar rays can track the sun. And this will help them, of course, produce more electrical energy to run the station. If it can track the sun, it does a better job at getting energy out. So their job that they did will enable our trust segment to be more productive.
On flight day 1, you and your crew will launch on board Discovery, then check out and configure systems for your stay in space. Then on flight day 2, there's a limited inspection of the shuttle's exterior. Can you tell us about that activity with the boom sensor system?
Sure, the boom sensors. The idea of that is just to make sure, we call it thermal protection system, and it's more specifically on this day, is the leading edge of the wing and the nose cap are in good shape. And we look at that very detailed with sensors. They can tell us if there's cracks, delamination, or any issues with this leading edge or nose cone. And we'll go over that very carefully. It takes about 6 hours to do that job. And after that, the data is sent to the ground where it's processed, and they will tell us if it passes or not for reentry.
Then the next day is the first of several very busy days for both your crew on board Discovery and the crew on ISS. Tell us about Rendezvous and Docking, how that will proceed, and specifically what you'll be doing for that activity.
Rendezvous mostly starts that morning of the flight day 3, and from then on, our whole task is to get ourselves in the proper position to dock with the station. And the way we'll do that, we'll set up different burns, we call it, to adjust our orbit to come up on the nadir or the below the station. And at that point, when we get about 600 feet below, we'll come in. That's when we do the flip maneuver, so they can take pictures of the belly and make sure the tile on the underside is okay. Again, another part of the thermal protection system. And then from that on, we'll move and get in front of the station, and then back on in and dock at that time. And that whole thing takes probably about 6 hours to get through the whole process.
And is it just Tony, Brew, and Joe that are going to be on the flight deck at that point?
No, on the flight deck, various people at different times. Definitely Tony and Brew are on there mostly. John is we call the Rendezvous MS. He's working a couple different systems. One is a laptop that helps give the trajectory, and so it's very nice to see exactly where you're going to be and where you're going. Type of program is called RPOP, and it's a wonderful program that we use. We also will have a handheld laser where you can take marks on the station to give us distance and a rate on the station. That is John's job. Joe and Tony are also up there. again, helping with the systems. And Ricky and I, our main job, we're called the Union Men because we work on the APDS, or the docking system itself. And for our main task, we don't get called in until about probably 45 minutes of docking. We set it up. Then again, just at docking, we have to work. So during that whole process, actually, we're downstairs doing EMU transfer stuff, getting other things set up for once we dock, the tasks we have to do right after docking.
Then on flight day 4, the focus turns to S6 and some joint robotic work between the shuttle and ISS. What's the plan to get S6 out of Discovery's payload bay and finally to the point where it will remain overnight?
Right. To take it out, we're going to use the station arm to pull it out of the payload bay, and Sandy and John will be flying that. They'll pick it up, move it on out. At that time, we'll have the shuttle arm grab S6, and that will be Joe and Tony flying that part. And once it's in the hands of the shuttle arm, it will move the station arm onto the MT and out starboard to the last part of where the MT can go, as far out as it can go, and we'll move then the S6 into a location where the station arm can grab it again, and once it will grab it again, take it away from the shuttle arm and move it into an overnight position for then on flight day 5, it will then do its last mover to put it into a pre-install position.
What happens in the unlikely event that one of the robotic arms doesn't quite work well or fails completely during this joint robotics work to get S6 out of the payload bay? What backup plans do you have?
Not much.
Yeah.
It's not a good day if that happens, because we need both arms most likely to get the solar array, or the S6 truss segment out there and installed. We do have some backup plans to maybe temporarily stow it on part of the station, but that would to be a lot of work would have to be done real time to get that done. And it also, depends on what failure. They all have different modes. They can make the arms, if only one thing breaks, they have backup modes and other ways to get around a lot of the failures on the arms. So hopefully it won't ever break fully and we would lose all capability.
The next day, you mentioned S6 will then be maneuvered into place for install. Tell us about the procedure that you and your colleagues on orbit will take to accomplish actually installing S6.
Well, first, John and Koichi are going to move S6 into the pre-install location, which is about 1.5 meters out from S5, exactly lined up, ready to come on in. At that same time, Ricky and I will be getting ready to do our first spacewalk, and hopefully the timing works out that we will be out the door and heading towards that area after John's got it all ready to go. We will get there, and once we get there, we will direct John on in and give him any kind of guidance on how he needs to change the current attitude or position of it so it's going to match up perfectly when it comes on into the S5. Once he does that, it's going to come on in, and Ricky is going to drive a claw around a bar on S6 that will pull in the S6 snug against S5, and at that point, hopefully everything will be good and we can drive the 4 bolts around on each corner that will hold it tight onto S5. At that point, it will be physically attached to S5, and from then on, we have to just do the electrical connections to get it on, and then get the solar array ready for deployment.
Okay, so S6 gets installed, you make the necessary connections for it, then you move on to some other tasks on EVA-1. Tell us about what else you'll be doing on that EVA.
As I said, the main task is to get the solar arrays ready for deployment. And they come in the launch config all bolted down. So we'll start off as Ricky will work on the solar array blanket boxes, which are these large boxes, probably about 15 feet long, 1.5 feet wide, 1.5 feet deep, that house each solar array blanket itself. and they are bolted down in a launch, as in a launch config. So he'll go and remove the bolts and the structure that holds it down so that they can be free to move up. He'll do the nadir side first and then the zenith side. While he's doing that, I will be working on removing a keel pin that's in the way. It has to be folded over a little bit. We'll be working on the MOD bolts, which is a get ahead later task. I will also, basically just getting coffee and watching Ricky do all the work. That's what my main plan is, leading the spacewalk. But since there's also a bunch of little tasks that I have to get done before those things can be deployed, and so I'll be doing all those, running around the S6, doing those while Ricky works his. Once he gets done with that, we can go ahead and release we call them beta gimbal assembly restraints. The mass canister along with the solar arrays will pop out, and at that point then we'll make sure it comes out all the way for each one of them. One goes up, one goes down, and then we have to climb on each one. I'll take the nadir mass canister, he's going to zenith one, and we have to then open up the blanket boxes so now they come out opposite of each other. They're launched in a more parallel config.
What options do you have if, for instance, the solar array blanket boxes don't unfold or something doesn't go quite right with the process of getting them to unfold?
We have contingencies for that. The idea is we'll go out again on a spacewalk, and hopefully what the problem is we can fix on a spacewalk. Of course, we don't know all the problems that could happen, but we've thought of a lot of them, and all the ones we've thought of, we've come up with ways we can go out on a spacewalk and aid the solar array to deploy. So it depends on, of course, what that problem is. There's things they've seen on other missions that we know how to do now, and we plan for. But hopefully anything that happens, we'll be able to figure out a way to do it. That's, again, one of the great things about the ground teams. They are ready to jump into action on any kind of problem we have and come up with a solution. And it's our job just to execute their solution.
How does the truss install on this mission compare to what you did on STS-117? And was there anything that you learned from STS-117 doing that activity that might help you with this?
That's very similar. The only difference is on 117 when we attached the S3-S4 to S1 was the bolts were driven inside by commanding. This time they're going to be driven by us EVA folks outside, and that's the biggest difference. Besides that, once we get out there and start deploying the solar arrays, it's exactly the same as the 117 mission. I didn't get to do that on 117, so I'm very happy to get to do it this time.
On Flight Day 6, there's currently a focused inspection schedule, but there's a chance you might not do a
Hopefully we'll
inspection.
not do a focus inspection.
If that is the case, if you're not required to do one, tell us about what will happen on that day.
Well, that's the day then we will deploy the solar arrays. And that's a pretty intricate process, even though it isn't a difficult thing to do in the sense of it's commanding from inside the station and the commanding is set up well. However, we have had issues on deploying solar arrays, so the process we go through is quite intricate in how long we can go each stage. It has to bake out in the sun to make sure that it doesn't stick together as much. So that's the process, and we have everybody has a job during that to look at the solar arrays that's coming out to make sure there are no issues with it. It's a very important thing because we don't want to have any problems with it or to damage the solar array during the deployment. So we'll be concentrating on that. It takes about 4 hours probably to deploy the solar arrays that day, and hopefully that will all go well.
Okay, so the ground will start the procedure?
It's a ground procedure and a crew procedure. The ground sets up the systems ready for deployment. We'll actually command the deploy ourselves on board because we have better views, even though they'll be watching very intently and have a lot of insight on the ground. But we do have the best view, so we'll be watching that. We'll deploy it out to about halfway, and then we let it bake out, which is in the sun for about 20-25 minutes, and hopefully that will work fine. Again, it worked well in 117, so hopefully this is what they've learned over the years. and then after that we'll deploy it the rest of the way out. But if anything happens during these deployments, we have always been trained to stop the deployment and do certain tasks to help it recover and still continue with deployment.
On the second spacewalk of the mission, you and Joe Acaba will tour the truss, so to speak.
Yes, we will.
Tell me about the work sites you'll be at and what you'll be doing there.
Well, we start off and we head off all the way to the far end of the port side, the P6 side. That's going to be interesting because now it was all just the one before that was on the S6 side, so the far other side. And over now I get to see the station from the far port side. So let's see if there's any differences. First, it should be wonderful though to be able to get that kind of views out there. What we were doing there, we're just doing tasks for other missions ahead of us to help them in their abilities to get the job done and make sure there's no issues with the stuff they have to do. So we'll be out there for a couple hours working on the P6, then we'll come on in a little farther to the P3 area and work on deploying a payload retention system that starts off inside the truss when it's launched. And the way it can work is you remove a few clevises and bolts, and you can swing it on out. It comes in like folded in, and you pop it out and it folds out like this. Then you can put the payload on top of it. It attaches and it allows data and power to get to the payload and holds it on at the same time. So we'll deploy one of those, and then we still have more get-ahead tasks, we call them, which is, again, tasks that help the station in its long-term operation. Things to do on the station to make it, maintenance-wise, be in a better configuration. So we'll do those, again, as we keep moving in on the P1 side. And then when we're all done with that, we'll go ahead and go back to the starboard side and do one more of those payload attached systems on the starboard side. And then we'll come on in.
Assuming S6 has been installed successfully and its solar arrays have been deployed, you're scheduled to turn your attention to some other hardware on EVA-3. Tell us about what's going to happen on EVA-3.
Well, EVA-3 to start off with, it's going to be Joe and Ricky out there, and their first task is a Cedar cart relocation. And a Cedar cart is a device we have on the station that runs along the front rail and attaches to the mobile transporter. And one issue we have is that we needed them both on the port side so that we can move the MT, the mobile transporter, all the way to the starboard side to install the S6. Well, the crew after us, or the mission after us, needs the Cedar carts mostly on the starboard side to do their tasks on the port side. So one of our jobs is to reconfigure those Cedar carts over to the other side. So that'll be the first thing they start off doing. From then on, Joe is going to work on more tasks to put the station in a better config for long-term operations. And Ricky will go to get on the arm himself and head off and work on SPDM covers. There are some of the tasks when they were putting the SPDM on a few missions ago, they didn't get to finish all the tasks they wanted to on the SPDM. And so he'll go finish those tasks. And then he will move on to a spot where they'll drop him off on the truss, but allow him access to the front of the Canadian robotic arm, where he will lube, we call it the snares. And when the arm comes in over a pin to hold on to, we call it grapple, a structure, it has snares that will close and wrap around this pin. Well, they're having, when it comes back open, it's not coming all the way back open. So we're going to lubricate those mechanisms that help bring it back open and close, and hopefully that will help in that. So that's going to be Ricky's job at that point. And then when they're done with those jobs, they're going to change, we call them RPCMs, where they're really just big circuit breakers out there on station. And they're going to change a few of those out, again, just to make the station in better configuration for long-term operations.
Can you give us an overview of what's going to happen on the fourth and final scheduled spacewalk of the mission?
The fourth and final is to start off, Ricky's going to go out and he's going to take infrared photography of some radiators on the station. There's been an issue with one of them peeling up and part of the radiator. And so he's going to take infrared photography of that one and also the one on the other side. and that way they can compare them and try to figure out exactly how much damage and what the damage is on the radiator. By that time, I'm going to head off to the Japanese laboratory and install a GPS antenna on top of that. And I'll come back and then work on a connection on Z1, just a connection that another crew before us had a little difficulty with. We found there's a failure on it, and they've researched that a little bit, now have more information. They think they have a way now to redo this connection. So I'll work on that at that same time. When we're done with that, Ricky's done with the infrared photography and I'm done with that, we will head on and grab we call WETA antenna, which has to do with the image you see when we're spacewalking out of our cameras on our helmets. That has an antenna that gets shipped, of course. We can ship it to the antenna, which ships it into station. We're going to put another one of those antenna out on the starboard side. So we'll grab that antenna, go to the starboard side, install that, and then do a few more of those payload attach systems. And that will be it for EVA-4.
After your work is done on ISS, you and your crewmates will eventually depart. You'll get a chance to pull away from the station and get your first big picture views of the station with a fully built out truss and all of its solar arrays. How do you think you're going to feel knowing that what you just did is going to help the station do more for more people in the future?
It's great. I mean, I know that's going to be a wonderful time because hopefully we'll have done our job all correctly and well, and it will be like that. And one, you get a good sense of satisfaction and accomplishment because you see you can see the fruits of your labor right there. It's all done right in front of you. And I remember from 117, it was a fantastic feeling as you fly over it and see the Earth below and you see the station floating there. It was just a great feeling to know that you worked on that and you helped it become a better place.